We are live, which means we can say we are live. Done. Thanks for joining us once again. I'm Sammy K. Powers, and this is the PHP Roundtable. This is a live podcast of developers discussing topics that PHP nerds care about. And the ultimate goal of this podcast is to learn a little something from each other. If you're listening live and want to chime in, we'd love to hear from you. You can ping PHP Roundtable with a question or a comment, and we'll try to get you in on this action if we can. So the demand for DevOps, these skills for DevOps, it's growing more and more in modern web development. And all the hype for this demand is usually met with myriad DevOps tools, as you're probably familiar with. And staying abreast of how these tools can actually help make our jobs easier can be a bit daunting. It's like a never-ending quest to learn new tools. Web developers these days have to really be skilled at learning new tools. So today we plan to make your quest a little easier by taking a closer look at a little DevOps tool called Docker. Now that we know that we're talking about, let's meet our panel, and in no particular order, we're going to kick this off with Phillip, or Phil Shipley, like shipping containers.
Mm-hmm.
Phil is a PHP dev for the past decade and has got addicted to containers, like Tupperware and boxes. And I hear that you were really into fish tanks at one point, right?
Yeah, and I drive an hour out of town just to get to the local container store, just to kind of walk around and look at stuff. So definitely.
So that's highly appropriate for this episode, since we are talking about containers. So welcome, Phillip, or Phil. Chris, Tankersley, Dragon Man Tank on Twitter. He is the PHP jack of all trades, and I added this little thing for you, and the master of all.
Oh.
And he's a
That's hard
DevOps.
to live up to.
Welcome, Chris.
Hello, thank you for having me back.
Absolutely. And I actually sketched just said on Twitter, he's like, yes, I made it. I actually I left one of the episodes on about Vue.js, and I forgot I had left it on Google Hangouts, and so Sketch was there, like waiting for us to go live at this time, and he had the browser window open the whole time, and was waiting and waiting and waiting, and he's like, where are you guys? So sorry about that, Sketch. I ended up deleting that. I didn't mean to leave that out there. So we're talking about Docker here. So what is Docker, and why is it something that PHP nerds even should care about?
So Docker is for the most part, it's going to be a deployment strategy for many people. It's very much like how we use Vagrant from a development perspective. You can get these pre-built images, use them to put your code inside of, and run your code for you. It is much nicer than a Vagrant box or a virtual machine because the images you use in production are an exact match for what you use in development. So even you even further reduce the "it works on my machine" problem, I find. And a lot of the stuff's smaller. It's easier to swap stuff out with. So I think it's a shift in how we do development, and hopefully a better shift.
So what is it that makes it different from something like Ansible, or something that provisions servers, or gets your installs all the software that you want on your servers and things like that?
Mm-hmm. Sure. Yeah, I think one of the main differences is that the Ansible, Chef, Puppet, SaltStack, all these software configuration management tools, they're really great when you need to apply configurations to a broad set of servers and you want to script that so that that's very repeatable and templatable. We use it a lot, or we used it a lot with in the Vagrant days as well, to spin up and configure a virtual machine. So you'd start at a very minimal base image, and then you would install the packages and configure them and do everything you needed to there. Docker is sort of, while those things can still be useful and can be used if you really want to, you almost don't need to because you've got a Docker file now. And a Docker file essentially describes every step of what needs to happen to build this container for your specific application. So it's no longer necessarily a full-blown virtual machine running multiple services and things. A container is intended to run a single service, so you essentially just install and run the commands you need, whether it's installing packages, copying in configuration files, copying in your source code, and then ultimately finishing the file out with what commands should be run when this container is started. So it's sort of different in that it can replace those tools, but there's still valid use cases for those other tools. I don't know if Chris has an idea on that.
Yeah, I mean, from my end, especially things like Puppet, they're much more used for configuration management. Ansible sometimes gets mixed with both configuration management and multi-server work, but really a lot of those tools are meant for compliance and making sure you stay in compliance. And it doesn't have to be something like HIPAA or these fancy, big, expensive things we have to keep in compliance for. But compliance in that these machines all have PHP installed. These machines all have these repos set up for Yum or apt, where containers really allow you to snapshot and freeze what the environment for an application looks like. And then you don't have to worry about making sure that if we deploy this new image, we don't have to make sure PHP is installed. It's baked into the actual image. So we can get rid of some of the headaches we have, and even some of the slowdown too. It's one of the projects I work on when we do our Ansible deploy. The actual product deployment is only 3 steps out of the 20 that happen. Most of the 20 are also making sure other packages are installed and up to date. So it's a shift in how those things work. If you have a lot of servers and make sure they run, you can run Ansible and make sure Docker's up to date and installed on those machines you're using. So they serve a little bit different purpose. I think it's better to think of the container images as snapshots as opposed to actual servers that we have to keep in compliance with tools like configuration management.
Mm-hmm. And it might be interesting too, just to point out that the containers are a lot like processes, but they still need a host to run on. So you still need this Docker host machine that has the Docker engine and everything installed to run the containers. So I do think there's still a place for Ansible and Chef and things like that for basically configuring and managing your host environment, and then you can just drop in your containers to run there. Because in a cluster of hosts, there are still tasks required for registering it with some central service, like if you're running Docker Swarm or Amazon service. But we might be jumping ahead of ourselves there a little bit. But I was all the way back to the beginning of your question there. How does it relate to Chef and Ansible? I was using Vagrant. I was writing a bunch of Chef recipes to build up our development environment, all that, and that was quite a pain and a headache because, as you said earlier, I'm a PHP developer, not really a Ruby developer, so messing around with Ruby and Chef was a challenge for me, and it was painful. Well, now I don't use that at all because all the commands I need are just line by line in a Docker file, and it's very straightforward, easy to read and maintain. So,
and it kind of gets back to all of your environments look the same. We use Scotch.io as our Vagrant box right now, which uses Puppet to configure, but we use Ansible in production. So anytime we make an Ansible change, we then have to make that change in Puppet. We can't really use the same thing. That's not a huge hurdle to overcome, but it's something we have to take into consideration because of the way we're set up. But with a Docker file, if I say I'm using the PHP 7 image, that's the same image my coworkers are using. I don't have to worry about it.
So you said that you likened it to a snapshot, kind of like if I was in AWS and I take a snapshot of the current state of my server, all the log files, all the configuration, everything will be exactly just as it would be if I restored from that snapshot. That's kind of what happens in Docker?
In a sense. So when you run a Docker file and you build an image, after each command in the Docker file, it takes a small little snapshot and freezes everything in place. So when you pull it back down, everything is as it was at that time. Now you can put your application in there, and there are ways to make some of those areas not snapshotted. You may designate something as what's called a volume, like var ww HTML, where your application lives, and you don't want that to be kind of snapshot. You want to be able to update code and stuff like that over time. But it does kind of freeze things in place. So the versions of software that are installed are always the same every time you pull down the Docker image. So if you built the image with PHP 7.0.1, that's the version that's going to come down until you rebuild that image completely from scratch.
Mm-hmm.
So it's
But like a snapshot, it really is can be 100% of the dependencies and source code, the server, the process, everything you need essentially to run your app. So, as we build new images, images get tagged, and so we tag them with current timestamp, or you can tag them with your commit hash or something as well. And so it makes rolling back on things very simple because 100% of what was needed to run the app was in that container, with the exception of databases. So, things like that you got to deal with. But from an application code standpoint, when you have to deal with things like, what happened with NPM, recently with that package just kind of disappearing and breaking a significant percentage of the internet because they were dependent on NPM to be able to pull in the package. Now you kind of mitigate that risk because you only need to pull down packages when you're building new images. Your old ones already have everything, so you're not doing a composer update or install in your production environment or anything like Chef might execute for you or Ansible might do for you. Instead, that's all run in advance, packaged as a binary image, and then shipped that way.
Mm-hmm.
So this is kind of like having a composer.lock file. You make sure that you have the exact version of everything in whatever state, or is it literally like a literal copy of everything from your vendor directory?
It probably depends on the application. Most of the time, you're probably going to have everything. So you'll have a copy of vendor as it exists. What I do with one of my projects, we build everything in Bamboo, and that Bamboo build artifact has a full vendor directory, all the npm stuff installed, all of that. During the Docker process, it will pull down that artifact from S3, dump that into the Docker file, and then that's all static, and I can deploy that image to any number of machines. So that as soon as that image comes up, it has everything that's ready to go. So it swaps out in about 2 seconds, and you're done.
Cool. So is it basically like adding kind of like a Git workflow to DevOps?
A little bit, because especially with being able to version containers, you can much more easily roll back. Like Phillip said, you can tag them however you want. So you can tag them with the release number, and if release 20 doesn't work, you can easily just pull down a release 19 and redeploy that. What's also nifty, because I've had to do this a couple times, I can then turn around and pull down release 20 locally, boot it up, because it looks exactly like it does in production, and see what was wrong at that time. I can rerun it against an integration server and find out, was it something that was with data? Was it something that just didn't build correctly? Did someone commit something? And like we recently just found out there's a bug in our build process that after we ran all the unit tests and stuff, we then accidentally ran a composer update every single time, which broke quite a few things when I turned that off, because you don't want composer update to just randomly run on update packages. But I can pull that image down and look at it and see exactly what was wrong, instead of rolling back production to get production back working and then trying to debug stuff on my local dev box, hoping that it looks the way it did in production. When I pull that image back down, that tagged image, it looks exactly like it was in production, because it's the exact same thing that was in production.
Mm-hmm. Yeah, that's a real nice thing, because with everything built in it, you can pull it down. You can basically, they call it exec into it, but it's almost like SSHing into the box essentially, and being able to just go explore the file system, check what processes are running, things like that. So troubleshooting and things like that become to be pretty nice for looking at that stuff.
Mm-hmm.
Cool. It sounds like with Docker, the main value is that you get something locally that is going to be as close to production as possible. Whereas like if you didn't have Docker, for example, you might be running Ubuntu 14 on your local machine, and you push it up to Ubuntu 16 or something like that, and then you have like all that potential for maybe differences in config or just something that will throw things off. But Docker kind of ensures that the configuration and everything in the environment is pretty much spot on, right?
Mm-hmm.
Yep. And even with a very tightly controlled configuration management system, like you said, your local environment might be Ubuntu. Like our Vagrant boxes are Ubuntu 14.04, but we deploy to AWS, so we use the AWS image. The closest I could possibly get that's CentOS 7 with some extra packages, but I'll never get it exactly like the AWS AMI. And then there's even little tiny variances where if the OS is the same all across the board, if I start the project 6 months ago, I don't update the software every 6 months. So I might have a slightly different version of PHP than what someone else has. So we're probably hopefully both on 5.6, but maybe I'm on 5.5. But then the brand new coworker we got installs everything from scratch and he gets 5.6. So you end up with little tiny variances like that with virtual machines, and that's kind of something we've had to put up with. But with Docker, if I pull down that image, if we're all using the same base image, we all get bit for bit exactly the same thing.
Yeah, I almost liken it to 10 years ago we would focus on building the golden image. And so when you're running in your data center, you're building these golden images that have all of the packages and all the configurations and everything you need. And then you just start installing that ISO on every server you deploy, because then it's consistent for you on every server. But it's huge. It's got everything that you might need and want in it. And so then the pendulum swung all the other way, and we started going to the software configuration, provision, just-in-time kind of thing, where we're using Puppet and Chef to start with a minimal OS and then only run the recipes appropriate for that box and install just those configurations as needed. But that required being run in the environment where that server was going to be and live and exist. And then now we've kind of come back towards the middle where we're really just in time building golden images specifically for the process and the app that we're running. And so we walk away with this binary image that can be deployed and run literally in a second or less. And it's extremely fast and convenient way to do that now. And when we were running, we used to deploy on Amazon with their OpsWorks product, which is like their Enterprise Chef hosted environment, and a deployment would take anywhere from around 15 minutes or something, because it was checking out the source and then running our composer update and then running database migrations and whatever else it had to do, and it was super slow. And now we use CodeShip for all of our continuous integration and deployment. And so CodeShip builds a new Docker image for us, executes our tests against it. So now we're running unit tests against the image that's going to be running in production. We push that image off to a registry, and that gets deployed to the Amazon's Elastic or EC2 container service. And the process of deploying the EC2 container service generally completes in less than 90 seconds. So, the whole deployment time is extremely fast now compared to what it was before, and that makes a huge difference for minimizing downtime and that awkward period of time where things are updating and so the app's not responding properly or something.
Cool, and you've actually written quite a few blogs about some of these kind of deployment strategies, right?
Yeah, a couple. We wrote we just built a little shell script we call ECS deploy here that can trigger a blue-green deployment on Amazon real easy, because the way that their EC2 container services functions, it works on these things called a task definition, and that's essentially how you define what containers need to be run, how you configure them, like environment variables, things like that. And then you define a service that is configured to run a particular version of a task definition. And so if you update the service to use a new version of the task definition, it has all the logic built in to basically do the rolling deployment for you. And so just to really simplify our deployment process, we've got this little script that can be run, and it works quite nicely. It's gotten some pretty good response on GitHub. We've had a lot of pull requests and stuff come in on it, and people are using it. So it really seems to be solving a challenge there that works very nicely.
Cool. Well, hopefully we'll get a link to that, and I can add it to the show notes a little bit later. Now, when we were talking, me and Phil were talking at PHP Tech about this episode, and I was trying to wrap my head around Docker, because I've actually never used Docker before, and he was using really cool terminology to help me understand what Docker images versus container was, and likening it to PHP. As in, Docker images are like a class, right? You create a class in PHP, and a container is an object, so it's like an instantiated class. Is that kind of what you were trying to explain?
Yeah, definitely. I think that's, in my mind, and the way I picture it, that's a great way to describe it. Is we write classes and they exist, and classes extend other classes, and very likewise, Docker images extend other Docker images, and so there's a very good number of what are called official base images that come from Docker, like a Ubuntu image or an Alpine Linux image or an Nginx image or something, and or even a PHP one. And then from those, every Docker image you create is always going to say from some image. That's the very first line of any Docker file says from, and then what base image it's coming from. So in the same way as our classes extend other classes, that's essentially how Docker images work. And they're now, Chris can probably talk about layered file systems better than I can, but essentially these Docker files end up creating multiple layers on top of each other through the whole copy on write concept, and each layer is a diff. And so anyway, all that just to say is, yeah, an image is essentially a class, and then once you start running containers, you get multiple instances of it, because you can run 50 or 100 containers of the same image. It's like instances.
Cool. So that's a lot of stuff. I like the. I mean, there's a lot of we were talking about layers and then the writing something or other there. So if we were to step back for just a second and think like, okay, I have never used Docker before. I'm familiar with maybe Vagrant, and I can do some provisioning on my own, or shell. I can write some shell scripts to get me to the place where I want to be. Where's my step one if I want to start implementing Docker? Like what do I do? You mentioned base images. So I just write a Docker file, pull in one of those base images, and just start writing what I want it to install in this base image kind of thing?
I mean, essentially, there are some good tutorials put out by Docker to help you explore the concept. They just had their 3rd birthday a couple months ago, and so as part of that, they put out a tutorial and organized a kind of a global birthday party and had new people kind of going through the tutorial. So, if somebody brand new, I'd probably recommend jumping in on that, because it'll help you see how a multi-container environment works and what the Docker files look like. But yeah, essentially, if you're thinking about your application and you think about your Vagrant script, what does your Vagrant script do in order to build up that environment? And if it's a Vagrant with a shell script in it, which was how I ran Vagrant for quite a while as well, that shell script can almost be ported to a Docker file in terms of you got all these commands saying apt-get install, and you can do those within a Docker file as well. And then you can tell a Docker file will copy my application folder into this path in the container, and stuff like that in a similar way.
And you can kind of do it in pieces too. A lot of times, starting off with a project, I'll just start running using Docker run commands and pull down the base PHP image and see what I need from there. And then, generally when I start out, I'm going to have an Nginx image, a PHP image, and a MySQL image. So we'll use those basic building blocks, start that up, figure out what I need to go, write down what extensions I need to install, and then start keeping track of that in a Docker file. So once I've got it kind of working, you can start building the Docker files. And once you have the Docker files built, then that kind of leads you into the Docker Compose files. So now our multi-tier applications can start to come up and work pretty well. For a website I just deployed, it's a 2-line Docker file because it's a static website. So I actually take Sculpin output, and the Docker file is from Nginx, copy output_prod to where it needs to go in the image, and that's it, because it's all I need for that application. Other ones I have, it's from PHP:7, so I get PHP 7, and then a couple commands to install libraries for for iconv and mcrypt and stuff, install those extensions, and then they go on their way. So it's like sometimes you can get away with 5-10 line Docker files. Some can get pretty complex if you have a very unique setup. But as you start to break out your application, you can kind of start to see where those pieces need to go, and you can build on as you go along.
Yeah, and I find that just like you would do in your development, you start this class and it starts out simple, and then it starts getting more and more complicated, and then you start realizing, well, I've got to create this other class and it needs similar capabilities, so maybe some of this should be refactored into a base image, and then I go from there. So we've worked to the point where we've got a base PHP 7 image, and then from that I'll extend and have a PHP FPM version of it, and then my application's built from that, because sometimes I just need command line PHP, so I don't need the extra FPM configuration and packages and stuff. So, we start base and just kind of extend and do it in the same way we would in our object-oriented programming.
Are there any best practices for setting up how you would structure those types of situations, like maybe in a typical LAMP stack? You mentioned you like to do Nginx as its own separate thing. Would it be an issue to have Nginx and PHP 7 in the same image, for example, or is there a best practice for how to structure that and how to extend?
Docker really kind of stresses the one process per container idea. Sometimes you can't do that for various technical reasons. But as much as you can get a single process in a container, the better. So, like I said, a lot of my PHP applications are an Nginx container, a PHP FPM container, and a MySQL container. The reason for that is if I need to swap out a piece, it becomes much easier. If I want to if I have an old legacy application that I know works in 5.4, I can have a 5.4 container. But then if I want to upgrade it to 7, I can take out that 5.4 container, swap in a 7 one real quick, and see how it reacts without having to go in and build a whole new image with Nginx and try to get that to work and all that junk. So it makes it much easier to swap out pieces when it's componentized like that. A lot of times people will say, well, I can run Apache and PHP in the same container. And you can, and still adhere to the one process per container, because Apache and PHP normally run as a single process. So like there is the PHP official image has an Apache version. And for me, that's perfectly fine because you're running PHP as mod PHP. But if you're going to separate stuff out and like you really love Nginx, I would put PHP in its own container, because also kind of getting back to the class versus object thing, you start to look at the single responsibility role. My PHP container should really only worry about PHP, not the database, not the web server. It should just worry about running the PHP applications. If I need to do something special with static files, let something else handle that, because there will be something better suited than PHP for serving static files.
So where would, for example, if I wanted to add mail catcher on my development environment, and I didn't want that to go in production, and I'm just thinking like how I'd structure this. If they're all just extending from each other, then I have like mail catcher extends, I don't know, base box, and then what extends mail catcher? Like how do you fit it into that architecture?
Well, the primary development tool or wrangler/orchestration utility that Docker has is called Docker Compose. So Docker is a whole bunch of different things. Docker is the main brand, but there are several different products involved in there. And there's one called Docker Compose, and it uses a YAML-based format for you to define multiple containers or multiple services and how they relate to each other. So what you'd probably do in development is you would have your Nginx container, you'd have your PHP container, and you'd have your database, and you'd have your mail catcher. You said mail catcher? Is that what
yeah.
So then maybe you'd have a mail catcher container there as well. And Docker Compose does some really neat things with automatically setting up the networking and routing between all of these containers for you, so that when you name each one, you give it some name, like it'd be called mail catcher. And so what happens then is the other containers that are defined within Docker Compose, they can all route to hostname mail catcher, and vice versa. They can route to hostname PHP or hostname Nginx or whatever, depending on how you define the network in there. But by default, they could reach each other and talk to each other like that. And so that's how you would run it in a development environment. And then when you went to production, you'd end up defining the environment a little bit different. You wouldn't have that mail catcher component involved. Most people use Docker Compose strictly in a development context, although it can also be used in more production contexts. And with some announcements that were just made at DockerCon this week, that might make it a more suitable use case of using Docker Compose in production and stuff too.
And there's some tools that actually use Docker Compose too, like Rancher, for example, can use a Docker Compose file for its production deployments. So you can go in and say, here's my Compose file, and have a production version that gets saved in Rancher. And then Docker Compose also allows you to merge together config files. So you can have a production one that gets shipped, and then a second development one that modifies the first one. So you say, start with the development one, append start with the production one, append the development one, and that development one says, oh, hey, we're going to set an environment variable in PHP to look at mail catcher instead of the local SMTP server, and then also define the mail catcher box. One of my real basic sites, I deploy through Docker Compose. So the production deploy is the main Docker Compose file, and when I bring it up in development, I just bring development up with the additional development Compose file. And so all the containers stay pretty much the same, except the the way I get my application into the containers and stuff like Mailcatcher. So it makes it really easy to kind of extend and modify Docker Compose stuff. And like Phillip said, some of the stuff that's going to come out in Docker 1.12 and the new versions of Compose and Swarm are going to make it much more attractive to deploy directly from Docker Compose and not have to have as much additional tooling as we kind of have to have right now.
And Docker Compose is actually part of the whole suite of Docker tools that you get when you install Docker.
Yeah, it's well, so it's a little bit tricky, and it depends on how you're installing Docker. So there's a couple different main sets of applications. You have Docker Engine, which is the actual thing that runs the containers and make sure they're running, give you the tooling to say, like, yes, it's running, let's stop it, let's start it, all that fun stuff, build images. You then have Docker Machine, which is a machine provisioning tool, which will actually talk to some sort of third-party service and generally create a virtual machine. So, like, there's a DigitalOcean plugin that when you run it, it will, for example, spin up an Ubuntu box, or you can talk to EC2 or Azure, a whole bunch of different things, and then install Docker inside that virtual machine that comes up. There's Docker Compose, which we just talked about, which is the orchestration part for your multi-container applications. And then there's Docker Swarm, which will take, it's a clustering tool for Docker nodes. So you can use Docker Machine to build 30 machines, and then take Docker Swarm and put them all together as one gigantic cluster. Those are the main applications you can download. They don't come usually as one bundle. Like on Linux, you have to install individual ones. Windows and OS X, generally, they all come in at once because it's a nice package everybody needs. But they're technically separate products, all under the Docker umbrella.
Yeah, it's actually really good timing for doing this as well to encourage people to check out Docker, because at DockerCon they announced that the Docker for Mac and Docker for Windows products, which are currently in beta, they were in a closed beta where you needed to request an invite. They're now generally publicly available, so anybody can go download them and get started. And Docker for Mac and Docker for Windows is definitely the easiest way to get started with Docker on Windows or Mac. If you're on Linux, you really don't need those. And maybe we should never really pointed that out, that Docker is strictly a Linux technology. It is it's based on C groups, which is a function of the kernel, and so on the Linux machine, you can run Docker natively, and all of your containers actually run as processes in your host OS. You don't need any virtual machines or anything to do that. On Mac and on Windows, because they're not Linux, you need a Linux virtual machine running with Docker available in there for it to run properly. And so that's what Docker for Mac and Docker for Windows do, is they utilize lightweight virtualization capabilities that are built into the operating systems to run a very small Linux virtual machine with Docker in it, and then they do a bunch of other tricky stuff under the hood to make a lot of networking things work and stuff. But by far, those two products provide the best Docker experience on Mac and Windows.
Windows Server 2016 actually has a thing called Windows containers. They emulate a kernel, so your containers actually run natively instead of having to run through Hyper-V. So that Microsoft has done a lot to get Docker to work and make it a very enjoyable experience on Windows. But that's only on Server 2016. If you're using Windows 10, you use the Hyper-V virtualizer, like Phillip said. And for OS X Yosemite, you can run the new stuff. If you're on any older versions, you have to use what's called Docker Toolbox, which was a bundle of like VirtualBox and a different ISO than what they use for the Docker beta. So that's kind of the one downside, is it's a really nice piece of software. The Docker beta is really, really nice, but you have to be on Windows 10 or OS X Yosemite.
Yeah, it's even Windows 10 Pro. So
yes, Windows 10 Pro. So like my laptop won't run it because I don't have Pro on that machine.
I'm curious if you have more details on just sort of the more nerdy aspects of Docker, like at the core. You mentioned like multi-layered file system read writing something or other. What?
So what Phillip had mentioned was this idea of a copy on write file system, and it has to do with the way Docker builds images. So what it does is, as you build a Docker file, every command inside of a Docker file creates a new layer. So it does an operation. Let's say it installs a bunch of software. It takes a snapshot and then does that. Then the next command runs and it makes a new layer on that. And then these commands just layer up on top of each other. But then you can start to share things between them. So if you have I'm pretty sure this is still the case. If you have the Ubuntu image already downloaded on your machine, and you then pull the Nginx image, the Nginx image actually shares a common ancestry with the Ubuntu image. So instead of downloading all 7 layers of Nginx, you only download the couple where they installed Nginx, because the other ones come from Ubuntu. The reason this kind of gets a little bit powerful is you can take advantage of that layering system to reduce the amount of time it takes to build machines, and be able to much more easily pull these things down. So if you are constantly deploying a PHP 7 application, and the only thing you're doing during your build process is throwing your files in to the image, when Docker goes to redeploy the new image, it's not going to pull down all the original stuff from Ubuntu and Nginx and PHP and all that. It's only going to download that layer that changed. So the download process is much easier. So it's kind of a nifty thing they did, where instead of it being a Vagrant box where every time I pull down the Homestead image or the Scotchbox image, that's a 300-400 meg download. The layer download may only be, the 20 megs it was to deploy my application, because the rest of it's all those other layers are sitting on the machine.
And do you have to explicitly declare what is shared between the layers, or is there like access to a global state, if you will?
It's based on the from image that you're using and the commands you're running inside of it. So you can branch off at kind of different points, and that's kind of where it does the stuff. But usually you're going to say, I have all these images that already exist, and it's only going to grab the top couple that it needs to.
Cool.
And really, for most people, it's probably not something you have to worry about too much. But it can be a cause of concern if all of a sudden your hard drive space is gone because of a bad way you're building your Docker file.
And I think that last point right there, Chris, is part of why Docker has been exploding like crazy, because this concept of containers is not new. They've been around for 10, 15 years or something with Solaris zones and C groups and other things. And but all the time, those were highly complex, very difficult to use solutions, and so you really had to be pretty advanced to do that, and that typically fell to some kind of advanced system administrator or whatever who was able to do that stuff. I mean, like Google's been running on containers forever, but that they had that capability to do it. What Docker has done, though, is lower the barrier to entry so low that it's available for all developers and operations folks who want to invest a few minutes to go learn the basics of it and get going with it. Like, I don't have to really understand how this layered file system works to build and use the technology. Now, I could probably use it better if I understood those things a bit better, but I don't have to know them. I can take advantage of the pretty great technology without that knowledge.
Mm-hmm. It's the same thing VirtualBox or Vagrant did for virtual machines. Mm-hmm. You install Vagrant and 2 other packages, and then now all of a sudden I'm building virtual machines without really thinking about it. I remember when I started using virtual machines, they were in a big giant rack, and I paid, I didn't pay, the company paid thousands of dollars for licenses to run VMware, and we had these massive, ugly, hard-to-use management tools. And now I can buy a commodity laptop, run Vagrant up, and I have 3 machines running inside my laptop now. The barrier to entry has been lowered dramatically when it comes to containers.
That's awesome. When I was talking with Phil at PHP Tech, you mentioned Kubernetes. Kubernetes, is that right?
Yeah, Kubernetes.
Kubernetes, yeah.
Yeah, what's interesting is a new paradigm or challenge that's introduced with this world of containers is a concept or a concern of orchestration. Like, how do you make sure these things are running? How do you make sure they can find each other? I mean, some of that's just a concern of microservices in general, is how does one service discover another service and know where it is? But even in the world of containers, it's easy now. Like Chris was talking about Docker Swarm, which allows you to treat multiple, basically physical hosts as one chunk of compute capacity, to the point that you don't have to know how many boxes are there, what the individual capabilities of each one are. You can just essentially just tell Docker to run things, and it will go find to the right place to run it. So when you have this stuff of, your container might be running on box 1, 2, 3 and data center 1 or 2, how do they know how to route to each other from a networking perspective? And when you say you want 5 copies of it running, how do you ensure that 5 copies are always running? And so orchestration is a big concept in this field, and there are dozens of vendors who are providing solutions to help with this. Kubernetes is one of those, and I mentioned it because it's one of the big ones. It is Google's infrastructure all runs on what they call the Borg, and the Borg is something they developed internally for managing and distributing and orchestrating all the containers that run everything at Google, and so they wanted to make that available to the world as well, and so they went through a process of I think it's mostly a rewrite in an open source fashion, and that's what is Kubernetes, and it's a very robust, very capable platform. It's sort of complex. Definitely a higher learning curve for Kubernetes than some of the other solutions out there. But what's neat about it is it's not vendor specific. You could run Kubernetes in your own data center. You can run it. You can use Google's Container Engine service, which is basically hosted Kubernetes. You could do Kubernetes on DigitalOcean or Amazon, wherever you want. So it provides an interesting opportunity for those who need to run in multiple locations to be able to have a very consistent way to do that. Personally, I don't have that challenge because we just do development locally on our systems, and then we're pushing to Amazon. So we're using Amazon's EC2 container service to facilitate the orchestration and management of our containers. But if we had a need to do things internally or across multiple cloud providers, Kubernetes is probably the route we would go to do that. Chris, do you use Kubernetes at all?
Not really. For me, and I think that you kind of stressed this point a little bit, Kubernetes solves a problem when I have lots of machines, like a couple hundred machines in data centers, and I'm really worried about a large amount of redundancy. Most people don't have that problem, I find. They're doing stuff like, I want to deploy to AWS. I have 3 or 4 Docker machines that we want to handle. So I think Kubernetes does definitely solve a problem. There are a lot of people that have this problem of, I need to orchestrate a huge number of things. For a lot of PHP developers, I find, we're worried about getting this application running in containers, and we might need to spin up, a couple instances of PHP behind it, a couple instances of Nginx. So there are a lot of tools that help us do that. The Docker stuff we've been talking a little bit about with 112 makes this much easier to get into. There's little tools like Rancher, which is a really good way to get into multi-machine deployment for no cost whatsoever. You run a couple Docker commands and you have a fully managed cluster running. EC2 or ECS is also another really good one that people can get into without a ton of overhead. That I find like Kubernetes and Mesos and stuff really have, but they have that for a very specific reason, and that's because they're designed for these massive deployments. Yeah. So I don't use it personally. I've looked at it, but again, it's mostly because I don't have that problem that Google has. Google has way more servers than I will probably ever physically see in my lifetime. So.
Yeah, and the other thing that Kubernetes does well that had me tempted on it for a little while, but with Docker 112, they released this new feature called multi-host networking, and there's this situation where when you're running a container on a host, if your container, let's say it's an Apache or an Nginx container, so it's a web server, and you want to expose port 80, you need to figure out how do I get traffic to port 80 in my container. So because the container is just a process running on a host, it has to map that port to some port on the host. So you can either map it and say port 80 in this container gets port 80 on the host instance as well, but you can only have one process bound to a port at a time. And so what happens when you want to run multiple applications on the same host and they're all web applications? Well, they can't all bind to the same port. So on Amazon ECS today, we've got this wiki that lists our couple dozen applications that are running, and we have to keep track of what ports we're allocating to each of those applications. So I say, all right, application A is getting the 10,000 block of IPs and ports, I'm sorry, and then the application B gets the 20,000 block or the 11,000, and we just basically give each one a set so that each application can bind to whatever ports it needs within that range, and it's okay. So this, it might all be very complicated or confusing if you haven't faced the situation, but Kubernetes solved the problem by virtualizing some of that and allowing you to bind to named ports. So even on the same host, you could just start saying things like using the name HTTP instead of a specific number, and it would go map that to whatever dynamic port got allocated to it. Docker 112 now solves that piece for you as well by assigning unique IP addresses to each of the containers in a way such that they can or different network interfaces and stuff to each one, so they can basically expose their port, bind to their port, and it facilitates all that stuff internally, so you can run multiple instances of the same container, same configuration on the same host, and it has some built-in mesh networking with load balancing and stuff, so that requests that come in can still load balance between multiple containers and find them and all of that. So that's really exciting. So they're looking forward to when they get that rolled out to Amazon, and it simplifies my configuration a little bit there more.
Yeah, like for me, we run reverse proxies for everything. So we have a couple dedicated machines that are just set up for reverse proxies, and those will spread back out to whatever machine they need to go to. So we might run 5 or 6 websites per box, but everything has to go through reverse proxy. So depending on how you set it up, Kubernetes does solve it very well. Docker 1.12 is going to solve it very nicely without a lot of overhead. So there are ways of doing it now, but like Phillip said, you got to kind of keep track of it or build your own to manage any of that stuff.
Yeah, I mean, we're trading one set of challenges and problems for another set, but for the most part, I'm finding it's totally worth it, because the benefits of having this ultra-portable container that I can run here or there or otherwhere, and the speed at which these things run and start up is just amazing. And so, anyway, I feel like those challenges are worth it.
So I really love what I hear about Docker, and I think it's going to definitely solve some common issues for myself when I start actually trying to implement it. One thing that I was when we were kind of talking, maybe some of the cons about Docker is that it is still kind of new and it changes often. Is it still changing a lot? Are they moving fast and breaking things like Facebook did back in the day? They still do, I guess, a little bit.
They don't break things near as much as they used to. Really, since about 1.10, maybe 1.09, they've been much more cognizant of backwards compatibility because more and more people are using these in production, and they're going to have a lot of angry people if every time they update their, from 11 to 12, stuff's going to break. And it used to break constantly. New features are added at a pretty breakneck pace, I find. And since they've sectioned everything out, Docker Compose can upgrade at its own pace compared to Docker Engine. So it is a very fast-paced and fast-moving technology, but it's, at least in my mind, it is a much more stable and viable production technology now. I don't worry about it breaking near as much as I did a year ago.
Cool.
Yeah, I agree, and I definitely think the environment that you run it on is quite stable and is not of much concern. The environment that's changing very rapidly is the desktop development environment. So that's been a real interesting and challenging environment if you're trying to do cross-platform work on applications that you want to run in Docker. That can be a pretty significant challenge, but I think what they're doing with Docker for Mac and Docker for Windows is getting better, and I think that when Bash comes to Windows 10 later this summer or whenever that releases, I think that's going to make the Windows developer experience a whole lot better too.
I mean, I'll be happy if everybody just switches to Linux. That just, I think it really is the best option. Everybody should just switch to Linux.
Agreed. Should we take a vote and just solve this now? Or?
That's fine. I mean, I only have 2 machines in my house that run Windows now. My laptop, which I have to keep running Windows for testing Docker, and then my wife's laptop because she refuses to switch. So, and we've only got 1 Mac, so everything else is all Linux. I forced my kids to run Linux. So they're all set for Docker.
Sudo bang bang.
Exactly.
That's what I'm going to name my dog, actually. His full name is going to be Pseudo Bang Bang Powers hyphen Franzak. Franzak's my dance partner's last name. So she keeps saying we need to get a dog, we need to get a dog, and I'm like, I'd love one, but we're always out on the dance competition, so it'd be like a lot of responsibility and cost for the kennel and stuff. But the perfect name for a dog is Pseudo Bang Bang. And then you have to explain it every time, like someone asks, so what's Bang Bang? What is that? It's like, well, in the command line, and then you spend 10 minutes later, they're like, eyes glazed over, like, oh yeah, that's gonna be fun. They'll just say, oh, Pseudo's a cool name.
Yeah.
It just has a nice ring to it. Well, so I want to start wrapping this up because this has been good discussion. We're kind of running a little bit over time, but that's cool. I do want to at least mention that on github.com/PHP Roundtable, there's a repo sitting there called show-notes. And if you're just listening along, you want to just sit here and write down and mark down, because like when you take notes, of course you write down and then mark down, right? I would highly recommend just sitting here and taking the notes and mark down and then posting those, or send a PR to this show notes repo, and I'll give you a shout out, personal shout out on the PHP Roundtable. I'll give you total credit and a link to your Twitter, your beautiful Twitter handle on the website. And it's just nice so that when people are listening along, they can sit there and click on the links. And like the one that Phillip mentioned earlier, I want to get that your gist or something. It was a gist or an actual repo.
For that script? Yeah, that'll give you the link to the article for us.
Yeah.
The GitHub repo, yeah.
Yeah, so that'd be good to get that resource. I do want to wrap this up with a developer shout-out, and that is this segment that recognizes a developer in the community for being awesome, super-duper amazing. I send them a thank you note and a $50 Amazon gift card from Laracast, because Laracast has been a long-time sponsor of the PHP Roundtable for the developer shout-out, and every month Jeffrey Way sends $100 to that we can do 2 episodes and send $50 Amazon gift cards to developers. So thanks, Jeffrey, for your long-time support. Laracast is the de facto place to learn anything Laravel and anything testing or IDEs and anything that you want to do with PHP. You just sit there and he takes you wherever you want to go and whatever you want to learn in the style of like Netflix, and you just pop some popcorn, eat, and learn some PHP stuff. I'm a personal subscriber of it, and it's fantastic. So thank you, Laracast, for the long-term sponsorship. For this episode, I asked the panel to nominate somebody special and amazing who's done a lot for the community, and they have nominated Eli White. So, Dragon Man Tank on Twitter, why do we nominate Mr. Eli?
So Eli has been a very long-standing member of the PHP community. I remember going to his talks way back when I started going to conferences. So he's given a huge variety of talks, WordPress development, security talks, all sorts of stuff. Not too many years ago, he and his company Musketeers Me took over the PHP Architect brand, which has been a long-standing community sponsor and conference setup that has been around for. It's an institution basically. So they took that over, and still to this day they've upheld that quality of conferencing and community that the original PHP Architect had. So now they have the PHP Tech, which has recently moved to St. Louis. They've introduced PHP World, which brings together a whole bunch of different framework people, and I think this is the 3rd year, and very excellent conference. And then now they're doing special things like the PHP Cruise. So he and his wife help facilitate all of that stuff to make sure that we have quality conferences and stuff to go to. So I think that's an invaluable service that not too many people can provide to the community. So I think it would just be great for him to receive this developer shout-out for all that he's done for the community over these many, many years.
Absolutely. So thanks, Eli, for everything that you've done, and I will be reaching out to you for your snail mail address and to get this gift card to you and the thank you note and a giant PHP Roundtable sticker. I've still got quite a few of those left. I'm trying to get them all done. I think actually at one conference I tried to hand Chris one of my PHP Roundtable stickers. It's a giant sticker, and he goes, "No, don't give me that. It's too big. I can't put it anywhere. I just don't even. I just waste it."
You've seen my laptop. I physically did not have it. It would have covered up like 12 of the other stickers.
Well, I'm telling people they should use it as a base sticker. You can like put it on the bottom, and then you put other stickers on top of it. It's like a sticker holder kind of thing. Sticker display.
I'll stick it on the bottom of my laptop.
I've got it on my coffee table here in my.
Oh,
office,
nice.
So that's where I put all my stickers, not on my laptops, but all over the coffee tables in my office here. So.
Well, it is a nice round sticker. So if you do have it like on a table, it could be like your official cup holder or cup placement device. All right. Well, let's wrap this up officially. The end here with some shameless plugs. Let's start with Phil. Do you got anything that you want to shamelessly promote?
Well, I think probably just as it relates to Docker, I think our ECS deploy script is pretty awesome, just based on the feedback and people using it. So I'll provide a link there, and then I'll also just say I wrote another article last week that CodeShip picked up and published about basically scaling down with Docker. Docker is often equated or associated with massive scale like Google, but the same qualities that allow you to scale up with it allow you to scale way down, and so you can save on resources, save on money, and scale down with it. So maybe the other thing I recommend is that article.
Sounds good. What about you, Chris? You got anything you want to promote?
So if you are interested in Docker, I do have a book. It's called Docker for Developers. It's at leanpub.com/Docker-for-devs. Really, really nice introduction to getting up and running with Docker, especially as it relates to us as developers. I also have, if you watch my Twitter, not as a general way to get people to follow me, but soon I will have a video series to go along with it. So if you can get actual recorded videos of doing that, plus maybe something new that may be coming along. So if you're interested in something kind of like Lyricast but very Docker specific, follow me and you'll know when that comes out. Hopefully within the next month or so.
Excellent. And you don't have to change the name of your book, or? No,
the book will stay Docker for Developers.
We were just talking a little bit about branding changes for at Docker, and I was like, I should add that to the show notes, and Chris is like, I don't think anybody cares about branding for Docker.
Yeah.
I was like, okay.
I am sad that I lost my awesome book cover that I had from Bo Simons's wife. So.
That sucks. Well, Sketch chimed in on Twitter, and he helped me figure out what I was trying to say when I was talking about the sticker on the table. And he says, I think you mean a coaster. So thanks, Sketch. That's exactly what I meant. Not a cup holder device thing. So our next episodes are going to be probably about event sourcing, and we're going to try to figure out what happened to PHP 6. I still haven't reached out to anybody on that one, so the dates aren't officially nailed down, very tentative, but those will be kind of fun episodes to get into. If you have something that you'd like to share on the PHP Roundtable, you have an idea, you're like, this topic needs to be talked about, or I want to talk about this topic, definitely hit me up. I'm Sammy K on Twitter, and you can also ping the PHP Roundtable, or just go to phproundtable.com and then fill out the form that says, I got an idea, or I want to join the Roundtable. Love to have you on the show. Thanks so much, Phil and Chris, for joining us in this episode. And we will see you guys in the next episode.
Thank you.
Thanks.
Yeah.
Peace.